Ignition sequence start.
Good morning, and welcome to Mission Control Houston and the International Space Station Flight Control Room. The specialists on console here are watching over the operation at the station systems and working with the Expedition 60 crew members as they near the end of a busy work week. Commander Alexei Yovchinin and his crewmates have been busy with science and maintenance this week, as well as getting ready for some special activities next week. A U.S. spacewalk on Wednesday, and the arrival of an uncrewed Soyuz spacecraft next Saturday morning.
Welcome to Space to Ground. I'm Isidro Reyna. This week, the crew prepared for an upcoming spacewalk. Expedition 60 flight engineers Nick Hague and Andrew Morgan of NASA reviewed procedures for a spacewalk scheduled for August 21st. During the spacewalk, the duo will assist in the installation of the International Docking Adapter 3 to the space station. The adapter will provide a second docking port to accommodate the future arrivals of the Boeing Starliner and SpaceX Crew Dragon commercial crew spacecraft. This will be the third spacewalk for Hague and the first for Morgan. An unpiloted Soyuz spacecraft will launch to the space station next week. The launch of the unpiloted Soyuz MS-14 spacecraft is testing the vehicle on the upgraded Soyuz 2.1A booster in preparation for its use for human launches beginning next March. This booster has been used for Progress cargo vehicle launches, but not yet for human spacecraft. The September launch of the Expedition 61 crew will be the last on the older Soyuz FG model booster. The Soyuz MS-14 will automatically dock to the station 2 days after it launches and spend 2 weeks at the station before it is deorbited for a parachute-assisted landing in Kazakhstan. The key to a long journey is fuel. This is as true in space as it is on Earth. Spacecraft use consumables like propellant and coolant to perform key functions such as maneuvering and maintaining critical equipment. The technology to replenish these crucial supplies in space does not currently exist. This week, the crew worked on NASA's Robotic Refueling Mission 3 experiment to enable long-duration, deep space exploration. This experiment will demonstrate innovative methods to store and replenish cryogenic fluid in space. It will also store the cryogenic fluid for 6 months with zero boil-off to demonstrate the efficient use of these important consumables. The resulting capabilities could be applied to exploration missions to the Moon and Mars. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Here are just a couple of NASA TV programming notes. Today, at 1 o'clock Houston time, we'll air a briefing previewing the upcoming spacewalk, as Isidro mentioned. Our coverage of the EVA itself starts this coming Wednesday morning at 5:30 Central Time. The spacewalk should start about 7:20. Now, later the same day, we'll have live coverage of the launch of the uncrewed 60 Soyuz. That coverage starts at 10:15 p.m. Houston time next Wednesday. And then we'll be back at 11:45 Central Time next Friday night, the 23rd, with coverage of 60S docking to the station. That's scheduled to take place about half an hour after midnight next Saturday morning. The spacewalk next week will be the third in the career of flight engineer Nick Hague. You probably know he's a colonel in the U.S. Air Force and an astronautical engineer by training. But that just scratches the surface. Here's the inside story on his favorite science fiction, his food craves, and the physical training that got him in shape to squeeze into a Soyuz spacecraft.
So we're an Air Force family, something you may not know about us. I met my wife at the Air Force Academy back in 1996 when we were in the same squadron. I was from Kansas, she was from New York City. We never would have crossed paths hadn't been for the Air Force Academy. So a question I get all the time is, are you a Star Trek fan or a Star Wars fan? But rarely does anybody ask me about Doctor Who. And that's a show that I grew up watching on PBS when I was young, and it got me hooked into sci-fi, and I think that's one of the reasons why I enjoy any type of sci-fi movie. So Doctor Who was a staple when I was growing up.
3.
Something that my wife introduced me to was yoga. And so we're regular practitioners of yoga. And I got to tell you, I am extremely thankful that she got me hooked, because being crammed up inside the descent module of the Soyuz capsule with your knees in your chest for hours on end is a lot easier after putting yourself through a few hours of torture doing yoga. I don't know if torture was the right word, but
4.
growing up in a small school, I got to play every sport. But the thing that really got me hooked and that was my passion was baseball. I was a pitcher, and so one of the things I did when I got to the Air Force Academy was walk on to the baseball team. And I played for a couple years there on the junior varsity team, and then got a chance to throw an inning at the varsity level. And then after that, they decided that my hobby was not going to go anywhere, and I got cut.
5.
So everybody has their individual tastes. When it comes to food, it's peanut butter and chocolate for me. That's an addiction I have. Who doesn't love a bowl of peanut butter and chocolate ice cream? The other thing that I really enjoy is crushed red pepper and garlic. If you put garlic on anything, it makes it taste better. So those are the things I crave when it comes to food.
NASA's Artemis program is focusing our efforts on returning Americans to the moon in a few short years and ultimately putting them on the surface of Mars. Those are both missions that'll need to solve issues with supplying crews with needed materials. Biomining could offer a way for crew members to obtain needed materials on other planetary bodies, rather than having to bring those things with them from Earth. However, microbes and rocks interact differently outside of Earth's gravity, and that potentially affects the output from extraterrestrial biomining. Well, there's a new investigation on the International Space Station studying how microbes grow on and how they alter planetary rocks in microgravity and simulated Martian gravity.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
Robotic technology, originally designed for the International Space Station, has found a new application in healthcare as part of a telorobotic technology to provide MRI-guided breast biopsies to women in remote areas. The Canadian Space Agency contributed to the production of this feature about the innovations coming from the Centre for Surgical Invention and Innovation in Hamilton, Ontario.
Space represents a fairly harsh environment. Any piece of equipment that's exposed to it over a long period of time would require maintenance.
So every time we have to do a maintenance on the outside of the space station, that means a crew member has to suit up and go outside. That introduces that crew member to risk and puts that person in harm's way. The other issue is that now they're spending the time doing the maintenance work and they're not doing the science, which is really what their purpose is. So with the maintenance challenges that we were going to have with the International Space Station, what we found ourselves was Canada being in the position to provide a solution to that problem, and Dexter was going to be that solution.
Dexter is a two-armed robotic manipulator system capable of performing fine motion tasks to replace what an astronaut would need to do on the exterior part of the space station.
Dexter is essentially a handyman. It operates on the outside of the International Space Station. It allows us to do maintenance operations. One of the advantages with Dexter is that we're able to control it from the ground.
And so the ground crew could actually operate these robotic systems and free the astronaut up from that task as well.
So now that Dexter's online on the space station and operating on a regular basis, what we've got is we've got a crew who's spending more time doing science. And this is important because this was really the whole idea of building the International Space Station, was to be able to do science in low Earth orbit.
Unfortunately, only about 40% of women should be getting annual MRI as part of their screening undergo MR screening. Part of the reason why women were not undertaking MRI screening was because of lack of access to the best radiologists locally.
Some women have to drive very long distance, like 7 or 8 hours of car in snowstorm during the winter, sometimes risking their lives just to get their MR-guided breast biopsies.
When we started to do the research with Canadian Space Agency and NASA on the whole remote telesurgery, we started to get involved with MDA. MDA is a Canadian company which has been involved in manufacture of all the robotic systems which is currently used on the space station.
So we developed a system called IGAR, which stands for Image-Guided Automated Robot.
IGAR is a tele-operated robot that performs breast biopsies under MRI guidance.
One of the capabilities of IGAR is to be controlled by radiologists from any distance. And that allows basic A radiologists to supervise MR breast biopsy on a patient who may be hundreds of kilometers or thousands of kilometers away from them. It means that the patient can undergo their breast biopsy in their own local hospital without having the need to travel to another city or another hospital to get access to the expertise.
And the results are very, very encouraging. So we've demonstrated that the IGAR is safe, extremely accurate as a human.
And this will allow us to hopefully increase the number of people undergoing screening close to 100% where it should be. So IGAR is built on many of the know-how which was developed for the space program, as well as the software which is also used to control the robotics on the space station.
We can actually see some of these technologies we worked with for a long time becoming available. We have a lot of insight on how to apply them, not just in medicine, but in a number of other fields, which is what we're doing. So without the space station, would any of that have happened? No, not really. Not in that way, anyway.
Whether you're in space or here on Earth, we, all of us, have trillions of microorganisms that live on and inside our bodies. They outnumber our cells by 5 to 1. But many of them are essential to human health, and because of that, there's one study on the International Space Station looking into how spaceflight can change those microorganisms and what that could mean for our body's internal systems. they're in orbit during long-duration spaceflight, the astronauts and cosmonauts can experience structural changes to their hearts, but exactly what changes and how they occur are not yet clearly understood. And that's why researchers are investigating cardiovascular stem cells, so they can better understand the role those cells play in the makeup of our hearts, as well as in tissue regeneration.
We're one of the first labs to be sending cardiovascular progenitor cells, so we know that they're an early population of cells. They're very potent in what they can become. We're able to create different types of cardiac tissue, whether it be cardiomyocytes, the heart muscle cells, or endothelium, the lining of blood vessels. These cells that we work with have the capacity to become a variety of different cardiovascular derivatives, and they function in a unique way in response to the environment and to different treatments. And so there's a lot that we can learn from these experiments. So the Kearns-Yonker Laboratory has been studying cardiovascular progenitor cells for a while and using them for cardiac repair, developing biologically active tissues. We'll be looking at disparities in the response of cells obtained from neonatal patients versus adult patients, and how that disparity exists at a molecular level. We'll be able to compare the microgravity exposed cells to the simulated exposed cells using the same clones. We'll be able to compare these two results and see if we can use simulated microgravity or even some type of microgravity-inspired treatment to help really promote cardiac repair. We're really excited for the spaceflight. We've been learning quite a bit even from the simulations, and we think that with the spaceflight we'll be able to truly extend these observations and hopefully promote cardiac repair, develop biologic active tissue, and even advance these insights into anticipating and treating illnesses in space.
For many experiments where the astronauts and cosmonauts are test subjects, there are biological samples that are produced that need to be stored in space before they're returned to Earth for study. And so where do they store these test results? Why, in one of a dozen large freezers, of course. In this Speedy Time segment, astronaut Jack Fisher shines a light on the Melfi, the minus 80 degrees laboratory freezer for ISS.
Hello, and welcome to another Speedy Time. Today we're going to talk about one of the most useful tools we have on the space station, the minus 80 lab freezer ISS, Melfi, or as I like to call it, the freezer of awesomeness.
The space station is for science, and we want to get all these samples we take back down to the ground. To do that, we need a big freezer, and that's why we have this baby. It uses a Brayton cycle with a wee little motor spinning at 87,000 RPM. That's fast. To get these freezers down to almost 100 degrees below zero. There's 4 75-liter chambers in each Melfi, and we have 3 Melfis. We have a bunch of other little freezers too, but this is the big daddy. So it's so cold, we have to wear these fashionable white gloves. Do you remember in A Christmas Story where he stuck his tongue to the flagpole? That's pretty much how it is if you put your hand on one of these. So to get samples back down to the ground, the Melfi cools down these wonderful little things called ice bricks. And then we put these in these super coolers and then send them back to the ground so that all of our science can be studied, and hopefully we find some cool results out of our experiments. I actually have a sample that I have to put in one. But to make it more dramatic and awesome, we've turned out the lights and we have backlighting so it'll just look cool. Come on, let's check it out.
And that, my friends, is the awesome super freezer that we have on the space station. Hope you learned something. Have a great day.
Scientists are using the International Space Station to learn more about the physical sciences, too. Researchers behind a number of experiments on the science of combustion hope they can uncover some ways to burn fuels so that the process produces less pollution.
The power of studying combustion on the ISS. Presented by Science at NASA. If you wanted to reduce the amount of pollution humans produce, where might you look? Here? Yep. Here? Sure. Here. Wait, what? That's exactly where scientists and researchers are looking, about 250 miles above Earth on the International Space Station. Here, astronauts are working on a series of experiments to learn more about combustion. Why combustion? Dennis Stocker, project scientist for the Advanced Combustion via Microgravity Experiments, or ACME, says, consider this. About 85% of the energy we use comes from combustion, the burning of some sort of fuel. About 70% of the electricity that we use at home and work comes from power plants that use combustion. The combustion of fuels powers the engines in many modes of transportation. Stocker continues, if we can learn more about the process, we might be able to find newer and less polluting ways to burn fuel. 3 series of combustion experiments taking place on the International Space Station's Combustion Integration Rack, or CIR, are looking at combustion in very different ways. The Flame Extinguishment Experiment, or FLEX, examined the burning of a single droplet of fuel in the microgravity confines of the ISS. The last of the droplet combustion experiments were conducted in September 2017. ACME began in November of 2017. ACME is composed of 6 major experiments, with each taking about 5 months to complete. These experiments will examine how various gases burn without gravity affecting the flames. The Solid Fuel Ignition and Extinction, or SOFI experiment, will explore the properties of burning solid matter. So why study combustion in microgravity? As Stocker explains, on the ISS you have conditions that you can't replicate on Earth. For example, consider a candle when it's burning. The flame flickers. Why? Hot gases from the flame rise, while cooler, denser air is pulled to the bottom of the flame. This flow occurs at high speeds, resulting in turbulence and instability. That instability makes it hard to study the properties of the flame. But on the ISS, there's no flicker, which allows us to make more precise and consistent measurements. If we have precise measurements, we get closer to learning how to burn more efficiently. More efficiency could lead to real cost savings for producing power. The research could also lead to reducing the production of soot and other pollutants. Combustion experiments conducted in space have contributed to practical applications on Earth, especially in the field of fire safety. A new type of fire extinguisher is just one example. And as Stocker notes, I think we're in for a few more surprises as a result of these microgravity experiments. That's because, not surprisingly, Stocker knew where to look for answers to reducing the amount of global pollution. He looked up. For more from the International Space Station, go to www.nasa.gov/station. If you're burning to learn more about other hot science topics, visit science.nasa.gov.
In supporting plans for future space exploration, the International Space Station is letting engineers who are developing those future spaceships work out their issues with systems that will support the human needs of the astronauts on those trips beyond Earth orbit. Systems like those that will provide clean water. In this installment of the STEMonstration video series, astronaut Drew Feustel discusses the water recovery system used to recycle crew wastewater for consumption.
Hi, I'm NASA astronaut Drew Feustel. Welcome to the International Space Station. On our station, our water recovery system is vital to our mission and our survival. Want to know why and how we recycle and filter our water? Let's go. We use water recovery and filtration because it is expensive to launch resupply missions, and the weight of the water is a problem as well. Think about the weight of a single bucket of water. Can you imagine the weight of water for a month's supply for 6 people on the International Space Station? What about the water for a year or more when we leave low Earth orbit for deeper space missions? That's a lot of water, and bringing it with us is not very efficient. On station, we recycle wastewater to get fresh drinking water. This recovery and filtration process includes our urine, moisture we exhale, and sweat, along with the water we use to bathe and shave. It works like this. When we use the bathroom, urine is collected and pumped to a distillation assembly. The assembly spins, pulling the urine to its walls. The urine is heated to evaporate water from the waste and then condensed in the outer chamber to form distillate. Next, the water is pumped to a tank where it is joined with the water recovered from cabin air created by crew sweat and respiration. Down the line from there, odors and any other contaminants are removed with heat. Then iodine is added for microbial control. Our water is checked often to ensure it meets water quality requirements. It is also monitored closely for bacteria, pollutants, and proper pH. The pH scale ranges from 0 to 14 and is a tool used by scientists to measure the strength of an acid or base. Our water is required to be in the 6.0 to 8.5 range. The end result of the entire process is clean drinking water that we get to enjoy every day. The recycled water on the space station is sterile. There's no odor or bad taste. You've seen that water recycling is critical for long-duration missions, such as here on the space station, and will be for future trips to the Moon or Mars. Be sure to check out the activity connected to this video so you can learn more about water filtration. Thanks for learning with me, and I'll see you next time.
If you'd like to get another look at any of the stories we featured today, check us out on YouTube and on Facebook. There are the addresses. And while you're there, look around, because there's a lot of other cool stuff you'll also find about NASA and America's human spaceflight program. And if you're out there on the internet anyway, check out Houston We Have a Podcast. Folks here at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday, and today Gary Jordan gets a tutorial on the environmental control and life support systems of the International Space Station from Laura Shaw, the program's lead for Exploration Life Support Sciences. Systems. So go to nasa.gov/podcasts. You'll find today's episode, all our previous episodes. You'll also find all of the other NASA podcasts, which are also pretty cool too. All of them are also available to you on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.